guys, Tarek Merryface, and welcome to part 3 of the Navigraph tutorial videos. Today, we're looking at the approach charts, and this is going to take a little bit longer. I went ahead and looked through some of these, and I decided to go for this one here because it's so ridiculously crowded. Now, and that's because there are three approaches on this. Okay, and so yeah, I thought it would be fun to have a quick look through it. However, rest assured that normally these don't look anywhere near as complicated as that one in particular. So let's go ahead and look at runway 05, uh, the VOR ILS-DME or NDB ILS-DME. So it's two approaches, but that uses three different nav aids. So the ILS, the DME, and the NDB. This part here is, sorry, I'll start from the beginning. The header, we are familiar with this, yeah? So we got the identifier and the name of the airport, the page identifier and the effective date, and then here you've got the type of chart, so what we're looking at, and then the town and country that this is in. This box here is what is called the briefing strip, and it's essentially a summary, okay? And so at the top of the briefing strip, you've got all the frequencies you could possibly need while coming into land on the final approach, once you're landed and going and taxiing on the ground. So you've got the ATIS, the approach frequency, the tower frequency, and the ground frequency. Here you've got a tiny circle, and that is basically the MSAs within 25 nautical miles of whichever nav aid or the airport itself. So in this case, it's from the VOR or locator because they're quite close together, so they're basically assuming that they're co-located. So within 25 nautical miles, these are the MSA heights, so the minimum safety heights. Here, you're going to have information about the nav aid you need, so we are assuming it's an ILS, so a precision approach. So you've got the ILS ILS identifier and frequency, the final approach course, and here you'll have a box which is usually a altitude or a point at which you can cross-check to make sure that you're on the glide slope while also being on the localizer. So in our case here, it's the DME distance for IUU, and at that point you should be at 1350 feet indicated. Now, because we've got so many different sort of approach minima, here instead of actually giving us, and we'll see why in a second, instead of actually giving us an ILS decision altitude, it says to refer to the minimums box, which is down below. And then you'll always have an airport and runway elevation irrelevant of which chart you're using. Okay, so differentiate between the two. In here you have the missed approach procedure in text, so it will describe the missed approach procedure. On the chart itself, it will appear as a dotted line, which you can see here. Okay, and it will give you information about when you need to turn, how you need to turn, and any other actions that you may follow. In some cases, some airports, the missed approach procedure will just be to climb at runway heading, climb to this altitude, and then follow ATC instructions. And then here we've got the information box, which we said is on every chart, and again, giving you specific information relevant to the chart. Coming down here, what we have is, of course, the diagram. And you can see it's quite busy here, but don't worry, it's not as complex as it looks. So here you're going to have the holds for the two different nav aids, either the VOR or the NDB, depending on which one you choose, which are expanded here. So the NDB, the locator, the frequency 331, GLW, and the Morse code. And then here you've got Glasgow, GOW, and you can see there's a little D here, which means that it's got a DME available. And then the Morse code right there. And then you've got both hold procedures, in case you were to do, for example, a full procedure approach for runway 05. You would do right-hand turn holds with a minimum holding altitude of 3,000 feet. Now, if you were to do a full procedure, you come out of the hold and then you do an outbound, and you're basically doing a teardrop approach. So you can see these two black lines. Well, depending on the category aircraft, they're saying how fast it is. So if your VREF speed is 90 knots or below, your category A. If it's above 90 knots up to, I think it's 135 knots, your category B. In those two cases, you'd go outbound from the VOR or the locator on a radio of 219 degrees until you hit DME distance 10.3, and then you make your turn. If you're a bigger aircraft, Charlie or Delta, so these are for higher speeds, you'd go out on the radio 206 degrees. And then you turn inbound as well. And what you can see here is that the inbound track, of course, is 050 degrees, which is what we saw earlier up, higher up today, earlier on. Now there's a lot of text, for example, all these DME distances, and they're all just points for you to verify. If you look here, so you see a chew. Now I saw this chew before I saw the chew on the other on the chart, so let me find it. There it is. Chew MHA 3000. So that's saying that the minimum hold altitude for the circuit is 3,000 feet. However, there's more information about it. So we go to chew and it says enter holding as instructed. Normally at 7,000 feet, your procedure normally commence via hold from not below 4,000 feet. So just like before, you find a number, you find where it is elsewhere with some text, and they'll give you more details about it. Now there's one here, which I believe the one isn't even on this chart, but it's up here next to the VOR ILS DME. And then here gives you information about the ILS. So in this case, it's giving you information about what to do if you don't have a DME or whatever it is. And then on top of that, below that, you have an alternate procedure from the VOR holding. Main procedure set for flight outbound, base turn, radio 219, category blah, 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 blah. Okay. Here we've got a restricted airspace, so keep note of that, especially since we could infringe it. Contour lines is great. You can see there's no contour chart. However, if you look at the contour lines here, you can see it says 1,000. So we can assume that anything that's cream colored is going to be 1,000 feet and above. And here the highest terrain is 1,713 feet. So we can assume that anything in here is between 1,000 feet or 1,700. And same with this one here. And you can see there's some obstacles here, 1349, 1581, and so forth. And you can see, if you're careful here, because you can see that there's an obstacle that's 455 feet high at DME distance 4. Now remember, if we go up here at DME distance 4, we should be at 1350. Yeah? So in theory, we should be clear of that obstacle by about 900 feet. But we keep an eye out, so it's why it's so important to follow the glide slope, make sure you're always on it. If you come down here, you will see distances and heights you should be at. So, for example, if you are doing a localizer only approach or the NDB approach, then you know at these distances you should be at these heights. So just a normal non-precision approach procedure. So at 7 DME for the IUU DME, you should be at 2310, and the GAL 7.4 2310, and so forth, looking at the different distances. And then here, that's where we do not our final check, but it's one of the main checks you should do. A lot of airlines, what they do, even on a precision approach, they won't do any of these, most of these, but they will do the 4 mile on the precision approach. And then on the non-precision approach, they will read out the distances and the heights that you're meant to be at and the actions you need to do to correct it. So for example, you got one pilot flying, the pilot monitoring will say DME distance 7, altitude should be 2310 on profile, or something along those lines. 2310, descend faster, climb faster, level off, whatever it is. If you look below here, you've got a box, and this is essentially this, but it's just a profile view. And you're going to get almost the exact information from here that you get from here and vice versa, except they're going to give you a few extra things here and there. For instance, here, you're not going to get the hold information, such as the tracks for the holds, and you're not going to get the missed approach. What you will get, though, is you'll get the outbound tracks, and you will get the fact that you should be descending from DME distance 4 down to 2,400 feet. So once you leave the hold, you can maintain your altitude 3,000 feet, and then once your DME distance 4 IUU or 4.4 GAL, you can commence descending to the platform altitude of 2,400 feet, where you will intercept the glide slope. Okay, And it's really important to reach this altitude, yeah? Unless the ATC instructs you, gives you radar vectors, you really have to be at this altitude when you intercept the localizer to ensure you're not capturing any of the fake glide slopes. And here you can see it gives you all these information about when to do such things. So here we descend at 4, as you can see here. And our descent point is going to be at 7.3 DME from the ILS. And then we descend on a track of 050. You see 2 arrows, one higher up and then the other. These are the missed approach points. These are the points you go around. Yeah? Middle marker here, I believe that is. And why are there 2? Well, depending on if it's a precision or non-precision approach. Here you got a 3, and the 3 says arrival not below MSA, descend in holding as necessary. So there you go. Just extra information. This little box here is great. This is basically, it tells you that we're doing a 3-degree glide slope. So you're descending at 3 degrees, which is pretty standard. In fact, most approaches do 3-degree glide slopes. And it'll give you, depending on your approach speed, how fast you should be descending. So if your ground speed is 100 knots, you should be descending at 530 feet per minute. And there's a quick way to do this in your head for a 3-degree glide slope. Take your ground speed, divide it by 2, and then add a 0. So for example, 100 is divided by 2 is 50, add a 0, 500, and it's pretty close to the actual thing. Yeah. So remember, this is based on your ground speed, not your airspeed. So if you have a ground speed readout, have a look at it. If not, then you're going to be using calculations. Here you've got the approach lighting systems available. If you don't know what all these are, then make sure to download one of the Jeppesen glossaries. They have a list of all the abbreviations. So in this case, you've got high intensity approach lighting systems, a category 2 high intensity approach lighting systems available. Add PAPI lights on the left hand side of that lighting system. And then next to that, you have the first 2 or 3 steps for the missed approach. So in this case, after the go around, climb straight ahead 3,000 feet or DME IU U5, whichever is earlier. And that's what the information says. I'm going to go back here quickly because I forgot to mention something. It said there's map at DME 0.5 or 0.9 gal. Now, and then you got these blank boxes. If you don't have a DME, and some approaches don't, especially non-precision ones, then you have times in these boxes. So it knows that once you pass the locator in the non-precision approach or whatever, a certain point, you can start a timer, and then once you've reached that time, depending on your ground speed, it means you're at the missed approach point. In our case, we don't need it because we can simply look at the DME readout, which will tell us when we are at the missed approach point. We come down to the bottom part here, and we have this, which is going to give us all our RVRs and decision heights. So it confirms it's a straight-in landing, in this case runway 05 for the ILS. So missed approach, and you see it's separated in these two because this is a bit more complex. Because we've got high terrain in the area, they have differentiated the minimums depending on your climb performance on the missed approach. So if you can exceed 3.3 degrees gradient, I think that would be net, then these are the minimums that apply to you. If it's 2.5, then these are the minimums that apply to you. So this is referring to lighting systems. So if you've got full lighting, limited lighting system, some lights are out, 1 or 2 bits of light are out, or the approach lighting system is completely inop, then these are the RVRs. However, if you can beat that 3.3 gradient, then everybody gets a decision altitude of 226 feet, which is 200 feet height, which is standard for an ILS approach. However, if you can't exceed 3.3, and you got 2.5 degree percent, then the decision altitudes will change depending on your category approach. The faster you are, the higher the decision altitude is. And again, depending on the type of aircraft you are and the lighting systems available, the RVR is different. So you just pick the one that's available. So for example, full lighting systems is available. We use this column, and if you're flying category B, for example, then your RVR is 550. Non-precision approaches. So as here it says lock, so localizer only, and here in brackets glide slope out. and here it says CDFA, a continuous descent flying approach or something like that. Essentially, what it means is when you descend in a straight line. There's no platform where you stop descending until you see the runway. That's an old-fashioned way of doing non-precision approaches, which has been phased out little by little because it's been seen as quite dangerous because you put yourself in a stabilized descent and then you come out of it, which is not the safest thing to do. But in any case, for non-precision, here's the DA. Now, quick thing, they call it the MDA. It's not really because Jeppesen don't add the 50 feet that most people do. So most operators, all of the ones I know of, will add 50 feet to that 370 feet plus 50 feet for 20 feet. So that's what you would use as a minimum. So if at 420 feet you don't see the runway, you go around. Then you've got the RVR's value here. This little box is for circle to land. So for instance, imagine there is a problem with the approach in such a way that you can't approach onto runway 23. For whatever reason, we can only use 05. However, as is with Glasgow, very often, more often than not, the winds favor runway 23. So you really should be landing on runway 23, but for whatever reason, you can't do an approach for runway 23. You have to do an approach for 05. Well, if the weather is within these minima, depending on your type of aircraft and the speed, then what you can do is you can do the approach, and then as soon as you reach that MDA height, or maybe higher if you see the runway airport, then you can do a sort of low-level circuit to go around the airport and do a visual landing. And I've done these on a simulator, and I've done circle to land in the aircraft in real life. They're good fun. It's very different. It's essentially a small circuit, low-level circuit, and you have to make sure that you can always see the runway. The final path, wow, I really can't talk anymore. You're going to be turning onto final a lot sooner than you would in a normal circuit, for example. And you can see visibility is 1,500 meters. That's below VFR minimums. In fact, the only way you can fly in 1,500 meter visibility as a VFR pilot is if you're below 3,000 feet, going less than 140 knots in controlled airspace. And that's something I really don't recommend for you to do. I may show you that in one of my simulators, my simulator sometime, just to show you what 1,500 meter visibility actually looks like. And that's it. So we've gone through it, and we've discussed a little bit what it looks like. So we've talked about the header, which we're familiar with. We've talked about the briefing strip, which is quite useful. We've talked about anything we might encounter in this area. And we've talked about the profile diagrams and all of these little boxes and what they all give you. So I hope you found this useful. I hope you didn't think that was just faffing too much. If you have any questions, feel free to ask me. If I don't know the answer, I'll do my best to try and answer those questions before coming back to you. And I'll learn something, so I'll genuinely appreciate it. Thank you for watching and listening. I'm Tarek Merryface. Make sure to subscribe, comment, and share, because that really helps. I'll see you guys next time, and happy flying.